Hey guys, Mr. Fraser here from Neil Maths, Bright Future. Today we're going to be learning about rationalising the denominator of a surd. Now, in its simplest terms, it's really bad practice to leave the denominator of a fraction with a square root sign in it. If we're ever asked to write a fraction in its simplest form, we need to make sure we get rid of that. And that's what rationalising the surd is. In previous videos, I've looked at multiplying and dividing with surds, adding and subtracting, dividing, expanding brackets, and this is going to definitely be my last video on the instruction on surds. I hope you enjoy it. Stay tuned to find out how you rationalise the denominator.
Fractions when they come up with the root sign down, lethal weapon in your mind, like a gun without a sound. No shortcut, no mark scheme, quit your chattering, it's your discipline, lets you stay true to your regimen.
Okay, so as I mentioned earlier, it's really bad practice to leave the denominator of a fraction with a square root in it. Here is an example, 1 over root of 2. Now, how could I write that so the denominator was not a square root? Well, as with all kinds of equivalent fractions, what we're actually going to multiply this by is 1. But we're going to write 1 in a very specific way. We're going to write it as root of 2 over root of 2. Why did I choose root of 2? Well, I chose root of 2 because I knew that if I multiplied the denominator of this fraction by root of 2 by itself, I'm squaring the square root, so I'll be getting rid of that. So I'm left with, on the denominator, just 2. And I'm going to multiply out the numerator as well. 1 times root of 2 is just root of 2. So what I've managed to do is I've managed to rewrite this as an equivalent fraction where the denominator didn't have a square root. This process over here is called rationalising the denominator. Let's look at another example. 2 over the square root of 5. Well, once again, we hate the fact that it's got a square root sign on the denominator, so we want to remove that. How do we do it? Well, we rationalise the denominator. So I'm going to multiply this fraction by root of 5 over root of 5. Whatever's on the denominator of the fraction, we write over itself. Remember, when we're finding an equivalent fraction, we don't want to change the value of this fraction. Root of 5 over root of 5 is just 1. Effectively, we're just multiplying this by 1. But we're writing 1 as root of 5 over 5. Let's simplify this. 2 multiplied by root of 5 is 2 root 5. And you know this, root of 5 multiplied by root of 5 is 5. Now, we always look at it and we ask ourselves, can we simplify it any further? In this case, we can't. Let's make it harder. Hate that it's got a square root on the denominator. Let's do something about it. Let's rationalise the denominator. Now, you could multiply them both by 3 root 5, but that complicates things a little bit. So all we're going to do is multiply it by root of 5 over root of 5. Let's simplify that. 7 times root of 5 is 7 root 5. The denominators, well, this is a little bit more complicated. Remember, this is the same as 1 root 5, so we could do 3 times 1, which is 3, and we're multiplying that by root of 5 multiplied by root of 5, which is just 5. And this time we can simplify it further to 7 root 5 over 15. We can't simplify it any further. Now there's just one more example that we're going to do, and this is quite a tricky one, but if you've understood what we've done so far, then I'm sure you're going to be able to do this next one. Now this is a much more tricky question. This is 4 over root of 3 plus 1. Well, if you're good with quadratics, if you know what I mean by difference of 2 squares, you're going to find this really easy. But I'm going to show you something quickly using algebra, which is going to kind of give us a little bit of an insight into what we're doing over here. What happens when I expand these brackets? Well, I get x squared, my outers are negative 2x, my inners are plus 2x, and my lasts are minus 4. So my outers and my inners cancel out. Plus 2x minus 2x equals 0. And my lasts, negative 2 times 2 is 4. Now we're going to do something similar with this question over here. In fact, what we're going to do in order to rationalise the denominator here is multiply it by root of 3, but instead of doing plus 1, we're going to do minus 1. root of 3 minus 1. Okay, and I'll show you why we do that now. Okay, now to solve this part, we just need to be confident in how we expand brackets. If you're not confident, go check out the video. We're going to talk through this part. Firsts, 3, outers, minus root of 3, inners, plus root of 3, and lasts, minus 1. We should be able to simplify that now. 4 root 3 minus 4 over 3 take away 1 is 2, and negative root 3 plus root 3 is 0. And we can simplify this last stage. And we're going to simplify that by dividing both sides by 2. So 4 divided by 2 is 2 root 3 minus 2. And that's my final answer. And that's it, guys. That's all we need to work on when rationalizing the denominator. This is a little bit more tricky, but again, it develops and it builds on all of the skills that we've been practicing and we've learned so far. I hope you found this useful. The key to Surds is practice. And with all parts of maths, Surds are easy when you know how. Please subscribe to my channel, like this video, comment below. This is Neon Maths.